Hello, so welcome back. And in this session I'm going to briefly cover how we can debug network issues within a multiplayer game that we've been working on. So in the previous presentation I showed this very simple demonstration, which is basically dolphins and an airplane flying around. Say for example this is the game host, and it is the game host. We can start to connect to this using a tool called the RN Visual Debugger, which is the ReplicaNet Visual Debugger, which is this application here. You can open a new view. This is actually an old Microsoft Foundation class multi-document view model application. So we just open up a new view here and press the connect button on the toolbar, and by default when the debugging code is enabled in the framework it creates a port on localhost, so we can just connect to that. And to indicate that it's connected, we get a little debug message here indicating that it's connected from this remote address, and this is the port number from the RN Visual Debugger tool coming into this game session here. Now this tool will capture the packets which are sent from whichever session it's connected to, and where those packets are sent to other sessions. So we'll need a second player to join to be able to capture those packets. So that's what we'll do now. I'm going to select this session and to join it, and I'm going to move the window to the other side. Now if I just stop the airplane from moving around, we can see in this window it's actually started capturing objects, and we can see that it's started capturing data packets. Now this is a live capture. So if I untick the filter and then say for example tick this object here, we can see that it's captured sending the object. So we can see here from session 0, which is this window, ID 0, which is object ID 0, which corresponds to the player object, was initially sent. And if I click on these here, we can see that it's sent some data historically. If I expand these, I can see when it's started sending positional updates. And what I can do is that if I move this and then stop it, we should be able to see, and then the window refreshes, we should be able to see where those position updates, or when those position updates are sent, and actually what is inside those position updates. We can also see the packet size, which is a good indicator. Now if I make this window a little bit easier to see, here we go. What we can do now is we can start to use this to debug network bandwidth issues. So say for example I want to create something to debug. So what I'm going to do is that I'm going to fly around a lot and I'm going to fire a lot of projectiles. Now because I'm firing a lot of projectiles, you can see at the bottom the graph is actually starting to show quite a lot of spiky data, and this corresponds with an increase in the bytes sent here. in the graphical view. The green line is sent, the red line is received. If I go to the other side and I fly around here, then fire some projectiles, you can see a similar pattern. So what does this tell us? Well, if we disconnect from the recording, just to basically stop it from scrolling around everywhere, untick all of these for now, and what we can do is that we can zoom out a little bit. I'm going to close these other windows too. What we can do, we can zoom out and we can scroll along. And we can scroll along to a point in time where we're quite interested in looking at the network bandwidth. So if I make this a little bit more obvious and easier to see, we want to know, for example, what goes on during this spike here. So I'm going to highlight it by clicking and dragging with the left mouse button. Now, when I click and drag, it filters the view for the time period that was selected in the graph, and it contains quite a few updates. So we're not entirely sure what's going on within these updates. I mean, there's quite a large number of updates. It could be any one of these, right? And if we widen the criteria here, there are going to be even more updates being set. Okay, so what we can do is that we can use the right mouse button now to select an area of updates that we filter out. So I'm going to drag it all the way over there and release. And what this does is that it takes the area that's highlighted in red and filters out all of those updates, only leaving the distinct updates. And if we only show the distinct updates, then we can see that it takes the updates from here, it then subtracts all of the update types and everything else for all of the other objects and just leaves the things that we're going to be interested in, the distinct, the unique ones here. And we can see here that the updates that were actually causing the majority of the spike were updates that were related to the projectile object. We can also see that there were updates for a new enemy object, but we can mostly see that we were looking at updates from new projectiles. So using this visual debugger, we're actually able to visually debug, hence the name, the network packets that were being sent by a particular network session. And this really helps to narrow down issues within the game when we see network issues. I've actually got a long play test which was captured during a play test of a game many years ago. And if I zoom out and then scroll around, you can see that at certain points during this different playtest of this different game, there were some network spikes. And if I scroll over here, we can see that we're interested in, say for example, this network spike here. If I highlight that spike, there's quite a few updates. If I then filter out all of the updates that I don't really want to include in the packet capture, like so, we can see here that this spike was mostly caused by quite a few function calls with some packet size, and then updating the deaths information. So what can we deduce from this? Well, we can deduce that actually there were 6 people, connected, because we can see that there are 7 people in total, but there are 6 other sessions connected to the main session. We can see that the function here was called and distributed to 6 individual IDs. And we can also see that the number of deaths, the variable for the number of deaths, was also updated and distributed to 6 other people. So we can use this very easily to try and debug network bandwidth issues. And it's quite a powerful tool. And it's helped me a lot when I've been developing games using this particular library.